Hello and welcome to the PyTorch Ecosystem Day 2021. Thank you very much for joining. My name is Piotr Bialecki and I'm the technical lead of the PyTorch team at NVIDIA. Today I have the opportunity to welcome you to this event and to talk a little bit about my personal journey to PyTorch. First of all, I will be talking about this whole event and how we can make the best out of it. This will be followed by my journey to PyTorch with my working experience with the community, where I'm seeing PyTorch right now and what the future of the framework might look like. The Ecosystem Day. The Ecosystem Day is a good way for the community to shape the future of PyTorch together. The Ecosystem Day gives you the opportunity to, for example, discuss core technical development of the framework, new ideas, and the future roadmap of it. Furthermore, it's a very good way to connect with all the maintainers and stakeholders of the framework. We will have a couple of talks like this at the beginning, which will be followed by a virtual poster session. Since I've been reviewing these posters and had the chance to peek a little bit into these submissions, I would highly recommend to visit this session and to chat about them. From my personal point of view, I'm mostly looking forward to meeting a lot of community members I might have interacted with in the past in one way or the other. My journey to PyTorch. So in 2017, I was working as a research scientist in the deep learning, machine learning field. And back then I was using a lot of different machine learning frameworks such as Theano and Torch 7. When PyTorch 0.2 was released, I really liked its NumPy-like API and its flexibility. It felt really natural to me and fit perfectly into my way of thinking and workflow. So that is why I completely switched to the framework back then. And at one point I was working on a specific segmentation use case with a custom loss function, and I wanted just to double check that my code is really working as I wanted to do. So that was the point when I created my very first thread in the forum, and a little bit later Sumit confirmed that my code is indeed working correctly. So then I thought, oh wow, the forum seems to be a really good place to learn more about the framework. And so I started to look into more forum posts and more solutions whenever I got stuck with a specific issue. And the more familiar I was with the framework, the more I started to help new users, especially to get started in using the framework. And once I was more familiar with the framework, I decided to start contributing to it. So at one point I was looking into the torch.split function, which was back then missing a more flexible way to specify the sizes. So I started with a feature request and started to work on it. And yeah, back then I wasn't really familiar with working on this huge code base. And my very first merge request was failing with a lot of linting issues. The rebasing wasn't working correctly. But I was really lucky that the PyTorch community is so supportive and has helped me to fix these things so that this particular feature was then finished by me. And from my perspective, I think this might have been one of the key moments where I decided to focus more on the work on the framework itself, which then led me to finally join in 2019 NVIDIA as a PyTorch dev, and where we are now supporting a huge PyTorch user base from, for example, internal as well as external PyTorch users. Since then, I'm still using heavily the forum, as it gives you a very good feedback loop of, for example, what new users are struggling with, where new research direction are heading to, and what the limiting factors of the framework might be at the moment. So we are using this kind of feedback to, for example, Suraj is now working on this specific FAQ section in the forum, or Shimon has been working on the, for example, PyTorch performance tuning guide. And since I've joined the forum, I'm still fascinated by the whole knowledge of the user base, as well as how welcoming the whole community is. I think once you're more familiar with the framework, it might be simple to forget what kind of struggles new users might have using the framework and getting started with the framework. So I'm really happy to see how supportive the community still is. And right now I have a little bit more than 20,000 forum posts, and I'm still learning a lot in the forum. Where I'm seeing PyTorch now. So PyTorch started as a niche research framework and is getting more and more features, more and more utilities, and a lot of things have happened since PyTorch started. So, for example, Chauhan has merged into the framework. We have a lot of domain-specific libraries, such as Hugging Face for natural language processing, Monai for medical work cases, or, for example, PyTorch Geometric. We have multiple high-level APIs. We have Torch script with multiple backends, which can be used to fuse specific operations if possible, speed up your scripted models. We have Torch serving mobile backends, which are more focused on the PyTorch deployment use cases. More users in the forum, more users working on the framework directly from a lot of different teams. The forum has right now more or less 3 million visitors per month. So you can see that there are a lot of new features and a lot of moving parts, which then basically leads me to the next point, which is, where are we going from here? So from my perspective, the 3 major points why PyTorch is successful is because of its flexibility, the performance, and the community. So the flexibility allows users to work on whatever kind of experiment they want. The framework should not be the limiting factor in your research idea. While the flexibility is needed, it is necessary for the framework to be as fast as possible as well. Combining these 2 points is not a simple task, and the usability shouldn't suffer from it. And these fast-moving parts and all these new functionality and utilities, it's really not that easy to keep up with, which is then why the 3rd point is you, the community. So you have been giving very valid feedback in the past and are still doing it, which is why we are basically all here today to shape the future of the framework together. So this leads me to a specific quote I would like to mention from Tom, where he says that he came for PyTorch, the library, and stayed for the company. While this is certainly the case for me, I really hope it is the same for at least some of you. So with that being said, thank you very much for joining again. Have fun and enjoy the day. Meet the complete PyTorch team at NVIDIA, as well as the whole PyTorch community.
Okay, welcome to PyTorch Ecosystem Day 2021. Thank you so much for being here. I'm so excited. This is great, such a great event, such a great way to get the community together, and a really nice follow-on from the Dev Day we did last year. If you don't know me, I'm Joe Spisak. I'm the product lead here at Facebook for PyTorch. And if you're part of the community, hopefully we know each other. If not, please reach out on Slack, reach out on GatherTown, find me later. I would absolutely love to connect. And hopefully you enjoy the keynotes from some of our most prominent community members, Peter Bialecki from NVIDIA, as well as Richie Yang. They're so passionate, such amazing people, and really proud to have them speak on behalf of the community. So today I really just wanted to update everyone on the releases we have, some of the newer features that we have as part of these releases. And I wanted to start with, just giving everyone a feeling for how we do releases and how we classify features. I think this has been something we've done in blog posts in the past, but just wanted to give everyone a refresher on the approach for how we actually do these major releases, which are getting larger and larger and larger, by the way. So first off, we do releases every 3 months, so they've gotten quite large again. So I think the last one had well over 3,000 commits between releases. So man, with over 1,800 contributors, there's a lot of code being pushed into the repo, so the project is getting quite large. We also do maintenance releases. So 1.8.1, which is a maintenance release, is a bug fix release, no features. And we try and do that. We try and have that kind of TikTok strategy of major releases and minor releases if we need them, and it kind of helps keep hopefully a good user experience. We also release on Conda, PyPy, as well as Docker. Those are the main distribution points for the project. We have docs and tutorials on PyTorch.org that are programmatically built and tested. So we have CI there. And that's maintained by our doc engineering team, but has a huge amount of contributions from the community around tutorials, doc fixes. Please keep those coming. The more the merrier. We'd love to see the experience continue to be improved. As far as releases go, this is not something we have a post on or anything, but how we think about features. So I think, if you look at the PyTorch.org site, we have the feature classifications, whether prototype, beta, or stable. But one thing that we started doing well over a year ago is actually doing a deep dive into every single feature, major feature that we include in the release. And so this is things like testing or breaking changes. Could also be feedback we've acquired, or the API experience, or op coverage. But we go through this very rigorous process for each feature, and it tends to be a very detailed kind of 2-page or 1 to 2 page document that someone puts together, and we take a look at it, and we figure out, number one, are we going to include this feature in the release, and number two, like, how are we going to classify it? We want to set proper expectations for every feature that we release. And to give you an idea, in the 1.8 release, we had something like 41 features that we reviewed, across the project, and that we dove deep on. So it is quite rigorous, and we do take a lot of pride in delivering a great user experience across PyTorch. Fifthly, we started doing about a year and a half ago RCs, so release candidates with every release, and we typically release these about 1 month ahead of an actual public release. And so we're, with 1.8, I think we generated something like 5 or 6 RCs. We fast iterated when we saw cherry picks that we had to pull in. This is a great way to test as a community, to give feedback early on before the release actually gets cut. So if you're interested, please reach out on the Slack. Yeah, again, it'd be great to get other eyes on these RCs, so we can make sure that we've addressed issues, but before we've actually cut the binaries. And then lastly, cloud support. So one of the goals we have is to make PyTorch as broadly available as possible in the most used platforms. So we do work with Azure, work with Google, and we work with the AWS folks to make PyTorch releases programmatically available in everything that they deliver, whether it's things like AMIs or VMs, all the way through to platforms like SageMaker and otherwise. And so our goal there is to basically have a currency level that is very close to time to market with our releases. It doesn't always happen that way. It tends to be more of the days or weeks, but our goal is actually to make that that turnaround, or that cycle time as quick as possible, so you have the latest releases on all the clouds. So hopefully we continue to improve in that regard. So looking at the actual feature classifications to provide kind of a click down and a little bit of color, we typically classify releases in 3 ways. Prototypes are bleeding edge features. These are features that probably aren't going to be in the actual release itself. They're typically behind a flag, or they actually tend to be more likely in nightlies. And this is actually a good thing because bleeding edge features are typically fast moving. There's going to be a lot of small fixes, a lot of new pull requests that pop up to make things, to improve things. And we want people to be able to quickly iterate. And so we tend to focus our prototypes there. We also have prototype recipes and tutorials and PyTorch.org that Holly on the doc engineering team created, which are really amazing. And so you can actually play around with some of these prototypes in like Jupyter notebooks and so on in Colab. It's really beautiful. Next is the beta level features. So these are features that are typically more committed, and we're basically committed to seeing these through stable. So in prototype we can kind of fail fast if we need to as a community and find areas that maybe aren't worth investing in or worth investing in. And then we typically will take those to the ones that we want to take forward into beta. And beta is going to be part of a release. Typically it's pretty feature complete, but maybe isn't performant, or maybe it doesn't have full documentation, or maybe it doesn't have full op coverage or whatever. These features are also not committed for backward compatibility. So again, these are typically very well implemented features, but they are being iterated on somewhat. So the API may change or whatever. But there are basically a number of features on the project that are kind of in this state. And what the hope is really to graduate those features into stable. And stable features are performant, well documented, typically have full op coverage, and from a breaking changes perspective, the goal is to basically have them as stable without any BCs. BCs, of course, still happen, and we do typically roll those over multiple releases. Typically have a warning, and then we'll do a deprecation. More realistically, though, we will actually keep things around for a long time. We want to make sure that we don't break people unless we absolutely have to. So now I want to just click down into some of the newest features from the latest release, just to give everyone a flavor of what we have going on. So starting with the front-end APIs, we have this thing called torch.fx. So this is a feature that was we didn't actually think it was going to get as broad of attention as it got, but the team was really pleasantly surprised on how excited people got over this. And so really this is all about functional transformations in the Python regime. So this is Python to Python code transformations. And more specifically, things like transforming your NN module. And so let's show a little bit of code and talk a little bit about more what torch.fx is composed of. So the actual toolkit, or the components are number one, a symbolic tracer. Number two, an IR. So it has this thing called fxIR, which is its own intermediate representation. And then three, it has a cogen in Python. So really three steps. One, you acquire a graph. You will, number two, write a transformation or write a pass. And number three, you'll generate a new module. And what we've seen actually is this is great for implementing things like quantization. So the new graph mode based quantization that was released in prototype fairly recently actually uses this under the hood. So we call it the FX graph mode quantization. We've also seen improvements in performance. So if you're serving, for example, your models, and you can actually write passes and do improvements and get latency benefits. And there's also some benefits, obviously, in training as well. So anyways, this is a general toolkit that please check it out, give us feedback, and let us know where you're seeing value. The next front-end feature is torch.linaug. So one of the big areas that we've invested in over time is really being as NumPy compatible as possible. So the next two features here are really all about that. How do we align so closely with NumPy's API such that very minor code changes allow you to take advantage of all the greatness that NumPy has, but also all the goodness that PyTorch brings, things like AutoGrad, things like GPUs. So torch.linaug module basically mirrors the np.linaug namespace in NumPy. So this is, again, things like Bialecki decompositions, determinants, eigenvalues, and again, very small code changes allow you to take advantage of all the goodness of PyTorch. Same thing with FFT. So this was a feature that we released in beta previously. It's now in stable. This is, again, NumPy style compatibility. So literally swap in your MPs for torches, and you basically get all the advantages of GPUs, AutoGrad, etc. And we're starting to see this be used broadly in scientific computing, which is really cool. So moving on to performance optimization and profiling. So this is actually a fairly big release we did in partnership with both NVIDIA as well as Microsoft. And what we've actually done is created this new namespace called torch.profiler. And underneath this namespace, there's actually a library called Kineto. And Kineto is in the PyTorch org. It basically provides the GPU monitoring capabilities and tracing. And there's also a TensorBoard plugin that is available in that repo as well. So we have a new API, we have GPU monitoring, we also support, of course, CPU. And there's a TensorBoard plugin, and this can actually be used in your VS Code. So you can actually be in your IDE using TensorBoard, profiling, and doing all the things you'd love to do in PyTorch, kind of all in one place. And so some of the things that it brings is the ability to obviously do your profiling of at the kernel level, looking at mem copies, etc., find the bottlenecks, be able to provide recommendations. So in this case, it's looking at your step time breakdown and actually telling you that, hey, like 21% of your time is actually being spent like loading data. That's a problem. So there's areas where you can actually improve there. So overall, basically, it provides you the ability to just generally performance profile and do some actual active improvements to your code. And then I mentioned you can visualize in TensorBoard, so you can visualize at the thread level, and then you can optimize and understand what's going on at the op level. And there's a number of different visualization ways you can look at this. So you can actually look at say like the top, pick your operators and understand which operators end up being the bottlenecks. You can actually slice and dice in a number of different ways. So this is really, really nice because you're already typically visualizing, things like your training loss curves, maybe your data, and now you're able to profile your code as well, all in the same place. So we're really excited about this. This is already getting a lot of excitement. And then the last major feature area I want to talk about is distributed training. Distributed training is, of course, part and parcel to how we scale into the trillion parameter models, how we, how the really innovation happens. How do we, increase our iteration speed, and so, a lot of things we've been working on, for example, like our RPC framework or TensorPipe, or some of the things I'll talk about here in a second, are all in service of training bigger, faster, and enabling either research or production scale models. So, if you look at some of the new features in beta, pipeline parallelism. So, giving a shout out to Mandeep Bains over in our Fair Scale team. We're looking at Fair Scale as this feature library that is really pushing the state of the art. It's a really cool library that has a number of bleeding edge capabilities, and this was one of them. And we actually worked really closely with that team to bring this into PyTorch Core. And so, for example, when you're training with your traditional DDP models, and you can't fit in a single GPU, this is actually a great API to try. It's a pretty simple API. You include it in part of your training loop, and this should certainly allow you to scale even further. The other feature I want to just call out is our DDP communication hook. This is almost a framework or a toolkit in itself, but basically what it does is it allows you to bypass the vanilla auto all reduce in DDP and actually insert your own communication strategy. And this is really interesting because there's a number of like built-in communication hooks that are just available at release. So we did include, for example, Power SGD and for gradient compression, which we've seen so quite a bit of benefit actually in scaling some models internally. So we'd love to see what benefit it brings for your models. But you can actually apply new strategies. So you can actually define your own communication strategy, plug it into this communication hook, and try something out yourself. So this is great for, using out of the box strategies like Power SGD, but also from a research perspective, really gives you kind of a tapestry to ideate on and create your new strategies and hopefully enable new research. And then the last thing I'll mention is, this was something that we've been working on for quite some time with the AMD team. We've been released in beta support for AMD GPUs. This is now in the install matrix. You can go to pytorch.org. You can click on the ROCm. We support 4.0.1, I believe, right now. And those are programmatically available through pip. And you can basically get AMD GPUs out of the box. And again, this is in beta, so we'd love to get feedback and let us know what you think. And we'll continue to work with the AMD team to improve support. So if you want, reach out to me, Jay Spisak. You'll find Jay Spisak on Slack. You'll find me on Twitter at JoeSpies. But if you're in the Gather town, please reach out. Love to chat, love to catch up, and enjoy the conference. Enjoy Ecosystem Day. And thank you, as always. Thank you for being part of the community. And absolutely love this community and love what you do. So keep on, and cheers. See you soon.
Welcome everyone. Excited to have you join for the PyTorch Partner Collaborations talk. My name is Geeta Chauhan and I lead the PyTorch Partner Engineering at Facebook. We will look at partner integrations and dive deeper into the profiling models, scaling AI in production, ML ops with Kubeflow pipelines, and ML flow. PyTorch ecosystem is rapidly growing and we put great emphasis on PyTorch as a platform with a wide range of ecosystem partner integrations built on top. These range from libraries like Hugging Face, OpenMind, to all the cloud provider integration and newer solutions like the MLOps platform integrations. Next, we will dive deeper into a few of these. For profiling models, we collaborated with Microsoft for the new PyTorch Profiler with TensorBoard Profiler plugin. We open sourced Facebook's internal tools for GPU monitoring as the Kineto library, which is built on top of cupd, and Microsoft contributed the Profiler plugin for TensorBoard along with VS Code integrations. Now one can see both the GPU and PyTorch level traces in a single view with actionable recommendations. It is a simple pip install for the Profiler plugin and comes with views for timeline tracing, high-level overview with recommendations, operators, and kernel views. Just call the import torch profiler and then set the context and pass parameters like GPU, CPU, activity tracing, record tensor shapes, and then in the training loop, call the profiler.step for the traces. In the timeline traces view, one can see all the CPU threads and the GPU streams and see all the PyTorch 8 ops and the CUDA kernels and user annotated record functions. One can see the flow of events from CPU to GPU and identify bottlenecks. You can inspect stats for individual activities. In this example, NVIDIA SMI shows 86% utilization. However, only a small fraction of the streaming multiprocessor on GPU are actually used. After we increase the input size, the WOPS per SM utilization looks much better. Here is an example of call stack for the PyTorch Lightning integration. All you have to do is launch the Lightning training with --profiler flag set to PyTorch and it automatically generates all the traces. Let's look at the overview of the profiler. You see here that we ran the test on a single GPU machine with one worker. You can see the execution time breakdown and the step time breakdown. And in the recommendation section, you can see the run is taking long for the input data loading with 20.8% of step time at data loading. It is telling us to set the number of workers on data loaders and enable multiple processing. Let's look into the actual code. You see here it's a simple CFAR10 model and we are loading the data with default number of workers. And then we set up the profiler context and we do the zero grad backward and then do the actual optimization. So let's increase the number of workers to 10 now and see what difference does it have on the profiling. So we run the profiler step again, and we can then see the output and see what is the difference. In meantime, let's look at the operator view. So you see here all the operators, top 10 operators are shown. In the GPU kernel view, we can see the top GPU kernels, you see the cuDNN kernels, call time, duration, etc. Now the second run completed, and we see that the extra time for data loading is gone and the time has reduced to 125 milliseconds. Let's look at the trace view as well. So in the trace view, you can see the profiler steps, the different steps that ran. You can select a bunch of kernels and see the details in the section below. You can select the GPU kernels and see all the details, the cuDNN kernels that are getting called. You can pan and zoom, go into the details of a specific profiler step and see all the optimization and other steps over there. So here we have the details of the GPU traces, and if you select a particular kernel and click on the launch for it, you can see how the flow is going from the CPU to the GPU. Now let's look at the tensor board in the VS Code. So we launch the tensor board command, and you can see here that the tensor board is loading inside VS Code. And you can see all the same views, the overview, operator, kernel, etc. You can move around, see all the details. So the two steps that we had run with and without the optimization, all those are visible here. So this is with the optimization, and this is the previous step that we ran. You can also see the trace view inside VS Code. So here the traces are loading. You see all the steps, the profiler steps. You see the CPU streams at the top and the CUDA stream at the bottom. There are two CPU streams and one CUDA stream. And you can dive and see that the profiler step has the optimizer step SGD. You can dive in, see the details. It takes 260.025 milliseconds. You can select a set of GPU kernels and see the details of those. For the scaling AI in production, in partnership with AWS, we launched TorchServe for model serving last year. It provides a scalable solution with model management, inference, and matrix API. It comes with default handlers for all the common ML tasks like image segmentation, text classification. One can write own custom handlers. It supports model versioning with rollbacks. And now one can do autoscaling with Canary rollouts and monitor using Prometheus and Grafana. We added support for a range of integrations, the Kubeflow KF serving with Canary rollouts, MLflow integration, Captum for model interpretability, AI accelerator support for AWS Inferentia, support for Kubernetes and all major cloud, the AWS, Azure, and GCP. A wide range of deployment models are supported across the different clouds and on-prem based on your needs. For the MLOps with the Kubeflow pipelines, in partnership with Google, we are currently working to integrate PyTorch into Kubeflow pipelines for model training with hyperparameter optimizations, visualizations in TensorBoard, Captum interpretability. We already launched the standalone integration of model serving with KF serving 0.5 release. This is what the full pipeline will look like, and we will provide sample workflows for computer vision and NLP use cases. So you will start by identifying the problem, collect all the data for analysis, choose the ML model and code your model, and then you will run the experiments in the Kubeflow pipelines using your PyTorch model training and do the hyperparameter optimization using Axe and PyTorch. And then in the production phase, you will start with the transformation of the data, where the PyTorch data loaders and the preprocessors will be used, followed by the training of the model, and then the packaging and deployment of the model on TorchServe KF serving. And for model monitoring and the performance tracking, you will take a look at PyTorch Profiler, Captum, Prometheus, and Grafana. The KF serving integration with TorchServe was launched back in Feb as part of the 0.5 release, and we are now working with Kubeflow pipelines. So let's look into a demo. So what you see here is a simple example of Kubeflow pipeline deployment. So this is a Jupyter notebook where we are doing the pipeline deployment. So we are connecting to the cluster here, giving the authentication details. So then we are calling the actual experiment, specifying the deployment task, and this is what the Kubeflow pipeline looks like. So this is for the BERT model. Then the pipeline is processing. So here the PVC was created, the model was downloaded, packaged, and it was deployed. And you can run the prediction and get the inference results. So for the MLOps with MLflow, in partnership with Databricks, we had launched the first phase of integration of MLflow with PyTorch last year with support for automatic metric logging for PyTorch models. We had added ML model integration with the examples for Hugging Face BERT and many more. For the model registry, we added support for saving the artifacts and also the ability to save and load Torch scripted models. And we had built the TorchServe MLflow deployment plugin for serving PyTorch models from MLflow itself. Now we are adding new features for support for Captum for model interpretability, support for model signature verification, and hyperparameter optimization using Axe and PyTorch. So the code that you see here at the top is for Captum integration, and you see the visualization at the bottom. And then the code at the bottom right is for the model signature. So this, if you want to do signature verification when your model predictions are being run, you can do that now with MLflow. And this here is what the code example looks like for hyperparameter optimization integration with Axe and PyTorch for best parameter search. Thank you all for listening. Please reach out to us on GitHub, do contributions. We are looking forward to doing active engagements with you. Thank you all very much.
Hello everyone, my name is Miquel Farré. I'm a Senior Technology Manager at Disney. I've been part of the engineering behind the magic for the last 8 years, and in my current role, I lead a distributed team of very skilled engineers and data scientists. We are all based across Europe, from Spain, Bulgaria, and Switzerland. I'm the one located in Switzerland. And today, I'm very excited to share with all of you a project that we started 6 years ago, the Creative Genome. Why did we start this project? Well, Disney has a broad and unique catalog. In that catalog, we can find different character universes. Within Disney's animated content, we can find different shooting styles, ambience, color gradings, and the same applies for live action content. Basically, each creative work has its particular style. On top of this, we also have outstanding programming around sports and news produced every day. We noticed that creatives from different parts of the company spend hours searching for specific clips of content. This is because content search and retrieval is a challenging task. In fact, for the ones here that were consuming content in the 90s, making an analogy between those mixtapes that we used to do and content archiving, we see similar problems. Most of the times, our only reference to the content of the mixtape was the sticker on it, which does not give a very good visibility of what's inside. The same happens in media archives. Most of the metadata is at title level. And even this title level metadata can be ambiguous. The scope of the tag love songs in the tape will need to be properly defined and agreed on to make that tag useful, especially if we want to search across millions of tapes. Allow creatives navigate content archives and search for specific moments motivated the foundation of the creative genome. Today, this index of descriptive metadata is accessible to all creatives in the company. Animators can use it to find appearances of a character with a happy face or to remember how the body of the character articulates when it jumps. New members of our writing room can use Genome to get up to speed on what happened during the last seasons, identify if something already happened in the past, and be coherent with the story in new episodes. Our consumer-facing platforms can use genome metadata in the recommendation engines. Marketing teams can quickly find moments using our index to create promotional content. And those are just a few examples of how Genome is being used. Let's take a look under the hood. Genome metadata is created combining manual tagging and automatic tagging that relies on machine learning models. Before working on a new model, the librarians that are part of Genome prepare the taxonomy that we will use. This is our way to clarify the scope of each of our machine learning models. The taxonomy defines which categories we should be able to distinguish with our model, keeping in mind the use cases that we want to cover. Once the taxonomy is defined, we communicate it to our team of taggers that will annotate manually part of our content. We use this manual tagging to create a machine learning model that we will end up deploying in production to continue the tagging. Done? Not yet. Our work is not done at this point. We have an active learning loop in place to trigger manual tagging QA and taxonomy adjustments. The manual QA is usually triggered to validate some challenging cases, and a taxonomy adjustment could be triggered by different reasons, based on performance. Maybe we don't need to differentiate between some categories that are causing problems. For example, we might not need to differentiate between stairs and a staircase in our generic locations model. Another reason that will trigger a taxonomy adjustment is the appearance of new entities in the content. For example, a new character or new fictional location in our favorite show. By the way, model training relies on tools from the PyTorch ecosystem, EMEA for multimodal architectures, and Optuna for hyperparameter search. Torch drift is one of the indicators that triggers the retraining of our models. Now let's focus on our inference pipeline. Given the volume and length of our content, we need to be highly efficient when we run inference across our archive. Our pipeline is end-to-end PyTorch based, and it works that way. Given a video and its frames, we split the video in segments using the iframes as boundaries. The workers on the PyTorch data loader take care of loading the frames in batches. We process the batches to select content keyframes. The keyframes will go through the selected machine learning model. And as a last step, the results might be aggregated with the inference results of other frames. The key advantage of this pipeline is that we move the content once to GPU and all is processed there. And this is possible thanks to the PyTorch data loader and Cornea. Overall, following the genome model creation workflow, we have more than 270 machine learning models in production. Some of those are valid for any content, and we occasionally retrain them, but most of the models are tailored to a specific franchise or series. We have all kinds of models. We can tag activities, events, fictional locations as well as generic locations, characters between others. Working on Disney's universe is particularly challenging. Let's take character recognition as an example. As you can see, the appearance of our heroes can be quite different in live action, comics, or animation. And on top of that, the appearance of the content also changes in different stages of production. Continuing with challenging examples, another case is the recognition of activities and events. The nature of those activities and events are different than the ones in academic datasets. For example, our activities and events taxonomy include terms like apology, loathing, or babysitting. Given the taxonomy in our scope, it was a natural fit to think in multimodality for this problem. Using PyTorch multimodal framework, we pass an image sequence, closed captioning, and audio information through custom encoders, and afterwards we fusion the output of the encoders to infer a result. This is currently work in progress, and we are experimenting in the fusion layers with transformers as well as feature concatenation. Another problem that we solve with multimodality is content scene splitting. We define a scene as a collection of shots semantically connected by the characters that appear, the topic, and the location. In this first example, we can see very different shots that an only video-based model could understand as different scenes, but the continuity in the audio signal helps us identify it as the same scene. In the second example, the audio signal helps us in the opposite, to identify that the boundary between shots is in fact a change of scene. Well, I hope you enjoyed this preview of Genome. I don't want to conclude before giving credit to Monica, Albert, Jordi, Cesc, Marc, Pablo, and Marcel, the fantastic team behind the machine learning workflow and the models that you saw. And if you wonder how we could go so far with such a small team, well, we owe part of the efficiency to the PyTorch community. On screen, you can see the ecosystem tools that we are using in production and some of the ones that we are currently experimenting with. We had the chance to meet some of the talented people behind those projects, and we also had the opportunity to discuss and share ideas with other individuals in the PyTorch community, like Robert Munro, author of the book Human-in-the-Loop Machine Learning, and the Facebook AI Partner Engineering team. This is definitely a good place to thank you for your help. Thank you. We will all agree that machine learning is an exciting area to be working on. It is moving at a high pace, and we see in PyTorch and its ecosystem a fantastic technology stack and group of people to experiment together, share knowledge, and move fast. We look forward to meeting you and discuss together. Thank you for watching.
Hello everyone, and welcome to PyTorch Ecosystem Day. My name is Suraj Subramanian, and I'm a developer advocate at PyTorch. Today I want to talk to you about you, a community of researchers, engineers, and hackers that has adopted PyTorch to push the boundaries of deep learning every day. Before I begin my talk, on behalf of everyone at PyTorch, I want to thank you for building an incredible community around this library. Thank you for being a positive community that welcomes beginners, shares expertise, and encourages one another to grow and improve. Thank you for being a productive community that is working hard to redefine the state of the art in AI every day. And thank you for being a creative community that, as you will see on the posters today, uses deep learning to tackle some very challenging problems in interesting and novel ways. Last year this time, we were using PyTorch 1.5, and today we are at version 1.8. Across these three releases, PyTorch developers have discussed more than 6,000 issues on GitHub, merged over 360 pull requests, and the number of contributors has increased to 1,800 today, almost 50% up from last year. The growth of the library could not have been possible without the community's enthusiasm and love for PyTorch. In the past 12 months, the forum has welcomed 14,000 new members, bringing our total population on the forum to 40,000. PyTorch knowledge, tips and tricks, and discussions about new features were exchanged over 58,000 posts. Last year, the time for a first response to any new topic was on average 25 days. Today, that number has dropped by 88% to just around 3 days, in a real testament to how responsive and communicative the community is. Frankly, it's pretty amazing to see the community band together and actively invest in each other's success. If you ever landed at the forum with a technical doubt or a query, there's a very high chance you may have found your solution from these forum champions. All put together, last year they contributed their expertise over 15,000 posts on the forum. A huge thank you to our community heroes. The value you create is truly unique. We are tremendously grateful to you for sharing your knowledge with the tribe. Just as PyTorch and the community around it grows, the number of projects that use PyTorch keeps growing. As of April, approximately 67,000 repositories and 2,700 packages on GitHub are using PyTorch. A much smaller list of projects using PyTorch is the official ecosystem. The ecosystem is really a collection of open source projects and libraries that enhance the experience of using PyTorch. Most of these projects are built and maintained by the community. This year, the ecosystem expanded to include 27 new projects, some of which are Lyft's L5 kit for self-driving cars, state-of-the-art NLP transformers from Hugging Face, performance acceleration libraries like Hummingbird and DeepSpeed, a multimodal AI framework for text and vision, model monitoring and debugging with Torch Drift, and libraries for hyperparameter tuning, experiment management, and distributed PyTorch. If you haven't already, go take a look at the projects in our ecosystem. There's something for everyone here. I want to share a few ways you can get involved with the community. First and foremost, share what you're using PyTorch for. The forums are more than just a place to ask your technical queries. They're also a great place to meet potential collaborators and kindred spirits. We have a newly created category on the forum for your projects. Please use it to share your ideas, demos, and code. If you maintain an open source project that other PyTorch users might find valuable, please consider including it in our ecosystem. We can also work with you to publish a blog on our Medium to familiarize other community members with your project. Last month, we launched a newsletter that rounds up curated news from across the PyTorch development world. You can subscribe to it to stay updated about the latest changes to the codebase, design discussions and RFCs for new features, and important events in PyTorch. Thank you for joining us today to celebrate our community. We encourage you to walk around and see all the posters. Personally, I'm super excited to see the incredible stuff our community has been working on. This is also a great chance to interact with the poster authors because they will be available for questions. Breakout sessions will be held and schedules are located throughout the event space. There will be dedicated time for networking after each session. We also have private spaces and the PyPorch for impromptu meetings and collaboration. Finally, feel free to get in touch with us. As developer advocates, we are here for the PyTorch community in a few different ways. We are here to answer your questions. We are here to listen to your feedback and help the engineering teams turn those into features. And we are here to keep you updated on the latest features and developments in PyTorch. That brings me to the end of my talk. Thank you for listening to me today.